Hi everyone. I just wanted to do one of the harder questions from section 3.4. So this is number 26. And so we've got a quadratic equation or a quadratic expression here in the denominator, which makes this a little trickier. So let's see if we can solve this. So we've got this quadratic, as I said, as our first denominator. So let's see if we can factor that. So using the AC method, we're looking for two factors of 9 that are going to sum to -3. So we could do like 1 and 8 or -1 and -8, but that's not going to work. And -3, or +3, +3, neither of those are going to work. We're not going to get to -3. So this one, then we would say is prime. It's unfactorable. So I'm just going to leave it like it is. I noticed there's a sum of cubes at the end there, so I'm hoping maybe once I factor that sum of cubes, I'll have something in common here. So this second term, we've got a binomial here, right? Two terms in the denominator. There's no difference of squares there. Those aren't squares. They're not cubes, so it's not a sum or difference of cubes. And those are the only ways we can factor a binomial, so we just have to leave that as it is. So I'm hoping this sum of cubes at the end, so I recognize 27 is 3 cubed, so I've got two perfect cubes here. So let's factor that and see what happens. And so if you need to review your sum of cubes, please do so. You do have this on your formula sheet. Okay, so we're going to cubic root the first term, which gives us a 3, and the second, or an x, and the second term, which gives us a 3. And then for our second set of brackets, we're going to take that first term of x and square it. Our middle term is those two numbers multiplied together, so 3 times x. And our third term here is the 3 squared, so that gives us 9. Our signs spell SOAP, same, opposite, and always positive. So that means this first one is a plus because our original sum of cubes was a plus, it was a sum. So same, opposite, so that one's going to be negative, and always positive at the end. Okay, and phew, that was good because look, you can see we've got that binomial in common and we have the quadratic in common. So we're going to have an LCD that's not quite so hairy here because it's only going to have two things in it. So let's say, okay, to figure out the LCD, so our first denominator we have there has just one factor, if you will. It just has this quadratic equation, or quadratic expression, I should say. The second one has an x minus 3. So if this is our first one, that's kind of like our A. B would be the second one. We've got some other thing here. And then our third denominator is the product of those two. So that means our LCD is going to be the same as our third denominator. It's going to be the product of those two factors. Okay, so I'm going to use the destroy method. You could just as well use the creation method here, but I'm going to destroy all my fractions by multiplying them by this LCD down here. That's a lot of writing, but it's worth it because we'll end up getting to cross a bunch of stuff off. So maybe I'll multiply them in green. So we've got our LCD here. Multiplied by our first term. And then we've got minus our LCD again. Multiplied by our second term. Equals our LCD. And there are kind of faster ways to write this out, and you're welcome to use them, but I encourage you when you're first learning this, writing it out is really good practice to remember what it is you're doing. So it's good to write it out even though it's a lot of writing. Like I said, it all pays off because in a minute we get to cross everything out. Oops, this is x plus 3 times our quadratic there. Okay, so now the very satisfying step, you'll go along and we'll be able to cross out all of our denominators as long as we chose the right LCD. So for this first term, my quadratics cancel, so that's nice. Remember, you could think of this LCD as over 1. So really, I'm just crossing something in the numerator out with something in the denominator, which is allowed. In that second one, I can cancel out my x plus 3's. And in my last one, I can cancel out my x plus 3's. I can also cancel out my quadratic there. So now I'm left with something a lot simpler. So I've got x plus 3 times 18 equals, oops, sorry, not equals, minus x squared minus 3x plus 9 times x. And then that equals, oh my goodness, sorry. I've got an x here on top, but that should be an 81 on top in that third term. Okay, so I've got 81, just 81. Okay, so I'm looking to solve this thing. So in order to do that, I should multiply everything out. So I'm going to distribute a few things here so that I can then combine some like terms and hopefully be left with something that makes it easier to solve. So I'm going to have 18x plus 54 minus, let's distribute out that x first before we deal with the minus. So we've got x cubed minus 3x squared plus 9x, and then we've got equals 81. Okay, now let's worry about distributing out that negative sign, so all of our signs within that bracket will change. So we've got minus x cubed plus 3x squared minus 9x. Okay, let's gather any like terms. So I've got two terms here with x's, those can be combined. And that's it on the left. So 18 minus 9 gives me 9x. Okay, now I'm going to move that 81 over so that I set this equation equal to 0 because I want to solve it. And so I've got 54 minus 81, which gives me negative 27. Okay, and so I can't combine anything else. I don't have any other like terms. I'm just going to write this in descending order, so highest exponent first. Okay, and I'm trying to solve for x here. So I would like to factor. First step would be to factor out any greatest common factor, but there's nothing in common to all four of these terms. We're dealing with four terms, so in order to factor this, we're thinking about factoring by grouping. So we're going to see what we can pull out of here and hopefully be able to pull the same thing out of here. So I can see I can factor out a minus x squared. If my first term is negative, I always like to factor out the negative, but you can actually do it both ways. So here I would get x, as in you could do it with a positive or a negative x squared factored out, and it'll still work out. So we get x squared multiplied by negative x squared multiplied by x. And then, so this is going to be divided by negative x squared. So I'm going to be left with negative 3 there. Okay, and so hopefully I can pull out an x minus 3 here, and I can if I multiply it by plus 9. Plus 9. Okay, so I'm getting somewhere now because I've got negative x squared plus 9 times x minus 3. Now there's a couple of ways to do this. I could actually factor that negative out right now. Or I could just flip it around into 9 minus x squared, and then it becomes a difference of squares that way. I think I'll factor the negative out. So I can factor a negative 1 out of this to get x squared minus 9. And then that's a difference of squares. So I get x plus 3 and x minus 3, and then another x minus 3. Or -1, well, we could just divide both sides of the equation by -1 and get rid of that. It doesn't have any x's attached to it. So now using the zero products rule, I could set any of these factors equal to 0, and the whole equation is going to be equal to 0. And this one's going to be the same. So my possible solutions then are going to be -3 or +3. So those are my possible solutions, is plus or minus 3. Let's take a look back at our original equation and look at restrictions. So I like to look at the factored one. So if you look at the factored one, x cannot equal -3 because one of our denominators is x plus 3. So x plus 3 cannot equal 0. So x cannot equal -3. Okay, so that's one thing to consider for our domain. Now, the other one's a little trickier. You've got a quadratic equation there that can't equal 0, but it's non-factorable. So that means whatever the answer is, it's either going to be imaginary or it's going to be decimals. It's not going to be a whole number. If it was a whole number, we would have been able to use AC method. Since our two possible solutions are whole numbers, I wouldn't worry about it then. So I would say our possible solutions are -3 and 3. We figured out that because of the domain, x can't be equal to -3. Our other possible solution is +3. If you wanted to double check your work, put in +3 and you should end up with a true statement up above. So our answer then here would be +3.